Okay, so you should have this pasted into your math log. And we are going to use this here to help ourselves understand interpreting remainders. Basically, what that means is we need to find out how we're going to use the remainder in the problem. Is it important? Is it not important? Is it really what we're looking for? It just depends on what the problem is asking. So we are going to look at 3 different ways that a remainder might be interpreted, and then we will go ahead and practice some problems where we see the remainder being interpreted in different ways. So I want to start out by talking about what is a remainder. So flip up your flap with me. So a remainder is the remaining amount left over when a number can't be divided evenly into another number. So for example, an answer might be 14 remainder 2, okay? Or sometimes we write it as 22 remainder 3, okay? Big R, little r, doesn't matter. So it's the amount left over when you're dividing and it just doesn't quite fit. It's the extra, okay? So let's look at some problems where that's true. So you should be looking at the flap that says, occasionally I use my remainder. So let's flip the flap up and look at a word problem where the remainder is used. So it says, Kim has 45 squares of chocolate. She splits them evenly into 8 gift bags and gave the extra chocolate to her daughter. How many chocolates did her daughter get? So we know she has 45 squares and she's going to put them evenly into 8 gift bags. And then her daughter's getting the extra. All right, so let's go ahead and figure out how many she's even putting in each bag first. Okay, so I'm going to go ahead and I'm going to start this off by doing 8 goes into 45. Well, I can't do that, so I'm going to put a 0 here. Just go ahead and put a 0 there. So I'm going to ask myself next, 8 times what gives me 45 or as close to 45 as possible? Well, I'm going to go ahead and I'm going to say that 8 times 5 gives me 40. And if I do 8 times 6, it gives me 48, and that's too big. So I'm going to subtract the 40, and I'm going to have 5 left over. There's nothing else to bring down, so I'm going to have 5 remainder 5, okay? So the question wants to know how many chocolates did her daughter get. We don't really care how many went in each bag, but we do care about how many she gave her daughter. So in this case, we're using the remainder. The remainder is the answer. So we're going to say that Kim's daughter got 5 chocolates, because that's what we care about in this case. Okay? So we're going to move on now to other times I round up my answer. So let's look at a problem where that's the case. Jordan needed 36 squares of chocolate, for a s'more cake she was making. Each bar had 8 squares of chocolate. How many bars did she need to open? Okay, so she needs 36 squares for her s'more cake, and each bar has 8 squares of chocolate. So let's figure out how many she had to open. So she needed 36, and there's 8 in each, so let's go ahead and figure that out. All right, so 8 can't go into 3. We're just going to write a 0 and move on to here. 8 times what gives me 36? Okay, well, I know 8 times 4 is 32. 8 times 5 is 40. That's too big. Okay, so we're going to use 8 times 4. And I'm going to subtract 32. And I'm going to get 4. There's nothing else to bring down. Sorry. So my remainder is 4. Okay, so we want to know how many bars she had to open. Well, she had to open 4 full bars, and then she needed 4 more pieces of chocolate. Well, she can't get those 4 pieces of chocolate unless she actually opens another bar. So in this case, we have to round up and actually say that our answer is 5, because she has to open another chocolate bar to go ahead and get that 5th bar, to get those 4 extra pieces. So she actually has to open 5 chocolate bars. Jordan opens 5 chocolate bars. Okay? So we actually need that many chocolate bars instead of just 4. All right. Here's the last one. Sometimes I ignore my remainder. Sometimes we don't need it. So let's see a problem where that's true. All right, more chocolate. Were 8 squares of chocolate in the Hershey bar. 3 friends shared the squares equally. How many squares did each friend get? Okay, so let's go ahead, and there's 8 squares. 3 divided by 8. So we're going to do 3 divided by 8. 3 goes into 8. Well, let's see. 3 times 2 is 6. 3 times 3 is 9. So 2. 2 times. Take away 6. 2. And we have 2 remainder 2. Okay? And we want to know how many squares each friend got. Well, each friend got 2. Well, we have 2 left over. Well, but we don't really care about those extra 2. That's not what we're asked about. We're asked about how many squares each friend got. So in this case, we are actually ignoring the remainder. So we're going to say each friend got 2 squares. All right. All right. So enough with the chocolate. We're going to go ahead and move on to some other problems. So once again, what you might see, excuse me, you might use the remainder, you might round up for your answer, or you might ignore it. So let's go ahead and look at some different problems. This ones do not have to do with chocolate. So Mandy wants to buy 4 books that each cost the same amount. If the total cost is $74, how much does each book cost? So she's going to buy 4 books, and the total cost is $74, and we want to know how much each book costs. So let's go ahead and do 74 divided by 4. All right. So 4 goes into 7 one time, because 4 times 2 would be too much. I'm going to take away my 4. Okay? 4 times 1, 7 take away 4 gives me 3. Next, I'm going to bring down my 4. 4 times what gives me 34? 4 times 4 is 16. All right, I need to go way bigger. 4 times 10 is 40. Okay, that's too big. 4 times 9 gives me 36. Still too big. 4 times 8 gives me 32. So let's do that. And then I have a remainder of 2. All right, 18 remainder 2. Okay, so how much does each book cost? Well, I don't know for sure, because I'm not going to change that into decimal. I'm not going to worry about that. So I'm thinking that each book costs just a little bit more than $18, I would say. Just a little bit more. So I can say each book costs a little more than $18. So in this case, what did we do with the remainder? Did we use it? Did we round up, or did we ignore it? You're right, we rounded up. We rounded up some so that we could say how much the book was. We had to round up and say it's a little bit more than 18. We couldn't ignore it. It wasn't the answer we were looking for, so we kind of had to round up some. All right, go ahead and try this last one on your own. it says that Gracie has 64 prizes. She will put 3 prizes in each bag. So how many bags will she have? All right. So 64 prizes, 3 prizes in each bag. 64 divided by 3. All right. 3 times what gives me 6? Well, that's 3 times 2. That gives me 6 exactly. 6 take away 6 gives me 0. I'm going to bring down a 4. 3 times what gives me 4? Well, 3 times 1 gives me 4. 4 take away 3 gives me a remainder of 1. 21 remainder 1. They want to know how many bags she's going to have. Well, it looks like she's going to have 21 bags because she's just got 1 extra prize and she can't make a bag with just 1 prize. So she's going to have 21 bags. All right, so what did we do with the remainder? Did we use it, round it up, or ignore it? Yeah, we ignored it. It wasn't important to our answer. We wanted to know how many bags of prizes she was going to have, not how many she was going to have left. We weren't concerned about that. So once again, there are many ways you can interpret remainders, and here are the ways that happen most often. Using the remainder, rounding up, or ignoring it. That can be really helpful when you are answering word problem questions, because sometimes if we don't pay attention, we might not actually write the correct answer. We might just assume, oh, they want the whole thing. But sometimes they don't. So it's important to pay attention to the wording of the problem.